welcome back to another video of H&H Express model and scale trains. Many of you already know that my layout is based upon an analog set, so DC, two rail system in nscale. Well, maybe some of you already noticed that on my control panel here at the below there is also a DCC-EX command station, and I would like to integrate that in my layout. I don't have any DCC, so digital command control trains running. I only have DC trains running, so the analog trains. But I would like to combine those two. So using the DCC system to control my train, but then in a totally different way. And I found a way in which it helps me to try to control the train as I want to. I'm using servo motor controls, so the motor drivers, to build up the speed of the train and bring the speed down to control it over the track. But I actually would like to have DCC send that signal and then catch that signal and send it to the motor driver, so that the motor driver does control the train in the right way. So let me show you what I have and what I'm using at the moment to figure that out, so that I can use DCC on my DC layout. And I will show you my control board, but I also will show you my DCC-EX, and I will go into that a little bit deeper.
So here an overview of my control board currently underneath the layout. So beginning at the top, from left to right, you have the relays which control the turnouts. And then next to that, you have the I2C bus to which all buildings are connected, and right underneath is the processor, so the Arduino Nano, which controls the whole buildings, so all the lights and the street lights, etc. On the right, you have the power supply that controls the power to the whole board. That is the 5 volt, the 12 volt, and that's currently what I'm using. So I'm not using any of the other outputs of that power supply. So in the middle, actually underneath the turnout relays, you have node number 2, which is the block sensor. As you can see, there are no sensors connected to it at this moment, because that's a work in progress. But next to that, you have node number 1, that is the CMRI node which controls the turnouts within JMRI. Then we have an empty node, and we have another power section node, and that is currently enabled but not being used. It controls, actually it should have controlled the power to the main track, but I decided otherwise to create a new power section, which I showed you in previous videos. I have the USB hub. This one is connected to my laptop, and it provides power to all the nodes. And here you have the DCC-EX control station. And next to that, there is a DCC Sniffer. And I will go into that, how that is connected, shortly. So here we are at JMRI, and you see that I have DCC++ over here. I will mark it with a larger arrow. If you click on that one, you can run traffic monitor, you can send a DCC++ command, you can configure the base station, you can check on the voltage and current, and if needed you can load DCC++ over a TCP server. Well, we will monitor the traffic. So at this moment there is no traffic going on here, and the sniffer over here did not produce any output. I will go into the sniffer a little bit deeper later in the video. So on the roster I have several trains configured. So I have a NS1127, NS1150, an NS1208, an NS2200, and they are all on different addresses. They all use the long addresses, not the short addresses. And what I did with the sniffer which I built, I concentrate only on one train, and that is DB, so from Deutsche Bahn, the ICE with address 935. Let me make this a little bit smaller so we can see the traffic monitor. At this moment there is no track power. So here you see the DCC++ on the control board, and you see that there are no LEDs lit. That means there is no track power. We have the traffic monitor within JMRI open, and I also monitoring the sniffer itself at serial port number 10. At this moment there are no packages because there is no power on the track. So if I'm gonna put power on the track, we see that the LEDs on the DCC++ lit, and that the traffic monitor reports that there is power on the track, and you see that packages are being received by the sniffer, except there is no code received. So what I did with the code which I adjusted, and I'm going to talk about it a little bit later, is I adjusted it so it only concentrate on DB ICE, or DCC code address 935. DB stands for Deutsche Bahn, and the ICE, that's the intercity from Germany. So if I'm gonna open the throttle, so here we have the throttle, and I don't do anything. Yeah, let me move it over here. So you can still see it a little bit. You can see here at the bottom the output of the serial port, and I added numbers to it so that you can see that there is progress. So if I now click on idle, it will tell me, okay, address 935, and it's the DB ICE, the code address 935. It is set to forward and it is stopped, and you see that the sniffer constantly sniffs the bus, and the number of packages is counted up here. So it's 28, and then we have 29 and 30, etc. So I can see that there is still a progress going on. On the DCC sniffer itself, it just reports that there is a throttle command sent, and DCC keeps on sending that same command on the bus. So if I open up another throttle, for example the NS1127, I'm gonna place that over the other throttle, and I'm gonna put that in idle. We see that the traffic monitor reports, okay, we have an address 1127, speed step 0, but there is nothing on this sniffer. And there is still power on the DCC. So on the DCC-EX webpage, under the DCC Diagnostics Tools section, you can find an explanation on what's a sniffer and what's an analyzer. You can build those sniffers yourself, or you can buy them. And the schematic of those sniffers are found here. So the schematics of the sniffers of a high-speed optocoupler and a diode, a capacitor, a resistor over here can be found here. It's easy to make, and I will show you the way I build it myself. You can buy those as well online. There is another good and tested circuit from Jeff Bunza, which has a little bit more components, but it's more stable. And I'm using this as the build which I made, except for the two capacitors around the 5 volts, because those are not necessary if you feed it directly from your Arduino. So here are the builds which you can just buy, order online, or you can create your own PCBs, like I did. So another good website to visit is Rudysmodelrailway. He created a DCC Sniffer, a packet analyzer with an Arduino, and he did that already in 2015. And he used a sketch which was built by somebody else, and he added some additional information to it. He also describes that in his video how the packet analyzer works with the Arduino, and I will put a link to that video as well. So what is actually needed? Well, to build it, you need to have the Arduino. In this case, I'm using a Arduino Nano. It's very simple to use. It's small, and you need to build your own sniffer, because this one is going to be connected to the Nano, and we want to isolate the DCC bus from the Nano, so we need to have a fast switching optocoupler. And the optocoupler would be a 6N137. So here DCC comes in, then we have a protective resistor, we have a capacitor to filter out the peaks, we have a diode, that's the 1N4148, then we have the optocoupler to isolate it, the DCC from the Arduino, and then we have two resistors, a 10K resistor and a 5K resistor, and the 5K resistor is connected to pin 2 of the Arduino, because the code which has been written uses pin 2 for the Arduino. You need to add 5 volts and the ground. So, and this is how it looks like from the back. It's just soldered on a breadboard, and I have cut some traces over here and over there. That is for the resistor. So I added some pins for the DuPont connector, so I can easily connect it to the Arduino, and I can also easily connect the DCC signal from the DCC-EX control station. So here is the code of the DCC packet analyzer or sniffer, and you can see that originally Robin McKay wrote that code in 2014. Rudy Boer changed that in October 2015, and I'm using the same code but altered it so that it only responds to one decoder address. So let me upload this one to the Arduino, and you can see it in the background that the Arduino code is now uploaded. Let me clear the output here, and you see that it updates every 4 seconds, and now you see that 935 and 1127 both are captured. So if I'm gonna open up another throttle, out of the way here, I'm just gonna put it to idle. You see that all 3 trains are being shown in the output. So, and that is not what I want to do. As mentioned, I would like to control one train on the track to set a different path. I'm gonna use the motor drivers to control the speed of the train at certain sections, and I just would like to capture one train. So if I'm now gonna, let me download my packet analyzer, which is called DCC Sniffer ICE version 104. If I'm gonna upload that one, I clear the output here on the serial port. You will see that all the information of NS1150 and the NS1127 is disappeared. So within this sketch I made some modifications, but I still added the information from Ruud Boer and Robin McKay in it because they wrote the initial sketch. So that is actually it for this video. I will do some investigation on how I can decipher more the information which comes from the DCC, and then try to initiate a full run on the track by moving the ICE over each power section and then controlling it via the Arduino Mega on the power build. And the power build you can find in the link here or there up in the video. So this is it. Thank you for watching. If you liked it, please give it a thumbs up. If you want to see more of these videos, please consider to subscribe to my channel, and I will see you in a next video. Thank you and goodbye.